everyone, welcome back to the GRE How To Series, where we make studying for the GRE a lot more tolerable. Today I'm really excited because we are going to be talking about geometry and like a moment of beauty that I've encountered with it. Stay tuned. Okay, yeah, I was a little bit dramatic about geometry, but I had a moment. I was going over the results of my diagnostic test and the 5-pound book of GRE problems, and I encountered just a problem where like I didn't get it right, and I was like, okay, why didn't I get it right? And I looked through the answers and it kind of unlocked something for me. I feel like when I encounter math, sometimes I just feel boxed in, or geometry joke, it was unintentional. Sometimes I do feel like there's like a sense of rigidity for some reason. Like I'm a really creative person, and for some reason in my brain, I just think that when I'm looking at math problems, there's no room for creativity. There are rules, and I must find the rule. And when I find myself with a problem where it looks like I know, maybe 2 out of the 4 steps to do, I just kind of get stuck at step 2 and I don't know what to do, and I'm just like, okay, skip it. So if this sounds like you and you can kind of feel my pain, I'm so excited to share with you just kind of the mental breakthrough that I had, and there are crafts associated with this video, which is really, really cool. All right, take a look at this problem. So we see that we have a square and there's a circle inscribed in this square, and we know that the area is 64. Okay, so when you first see that, it's like, okay, great, the area is 64. And then you go straight to the quantitative comparison and you're just like, cool, how do I figure this out? Well, don't worry, I'm gonna walk you through it step by step. Now, let's first look at the information that we have. We have the fact that there is a square and there's a circle, and the area of the square is 64. Now, when we look at the square, we know that if we can, bring in that elementary math, is that all the sides are equal. That's good to know. And when we look at a circle, we know that's 360 degrees. Cool. At first, when I see that their area is 64, I'm like, okay, cool, so what? But when you really look at the whole entire picture, that actually reveals 3 key things for you to figure out what to do with this problem. First, because it's a square, we know that if we find the square root of the area, we're going to be able to find the lengths of each side of the square. In this case, each side is 8. Cool. Let's hold on to that bit of information. Next, we know that there's a circle inside it, and it touches from end to end. That means that the diameter of this circle is also 8. Good. And then the third thing, we know that if the diameter is 8, then that means that the radius is 4, because it's half of it. With that bit of information, we have enough tools to figure out how we're going to move forward. Okay, so let's pause and just admire how much information that we can get from just one sentence. The sides, the diameter, the radius, like, it's pretty exciting, right? You might be a whiz in geometry, but I am not. And I am just I'm enjoying the learning experience, okay? Ride with me, ride with me. All right, cool. So let's see what we can do next. We need to figure out the area of the shaded corner of the square. And when I first saw this, I was like, oh, well, maybe I can use what I learned from finding the area of arcs. And if you haven't seen that video, click up here for a really quick primer on what to do to try to figure out, the lengths of arcs and things like that. I was really excited once I figured that out. Unfortunately, it was not really applicable, or I at first couldn't really figure out how to make this work. And I was just like back to like my stuck side again. I was like, okay, well, I've got this information. I'm trying to apply this arc thing, but it's not working the same way that I thought it should work. so I don't know what to do. And the reason why it doesn't work is because we're not really concerned about the length of that part of the circle. We're trying to figure out what the area of the outer corner of the square is. Now this is the part where I'm just like, okay, does not compute. I have kind of reached the end. And this is where you need to kind of do a mental backflip or try to figure out how to approach this in a different way. So check this out. I've got this square, right? So if I go ahead and take my sparkly scissors and cut a circle out of this square, let's see how carefully I can do this. So that is all the way cutting out the pieces. Okay, that's not that bad. I've got the circle out, and now I have a very fragile hollow square. Use your imagination. But I just want to know the area of this shaded corner. So I can really just cut the quarter out. So if I, this is me cutting it in half, boop. This is me cutting it in half again, so I have the quarter, and here it is. I just need to find the area of this piece. Now, arts and crafts aside, we literally did what we have to do mathematically. So, since we have the information to figure out the area of the circle, that can be subtracted from the square. And we know already that to find the area of the circle, it's just pi times the radius squared. I mean, at this point, all we have to do is just say 16 pi and leave it there. We don't need to multiply 16 times 3.1 blah, 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 blah just yet. We can just kind of estimate and just say that's 3 and we know that it's more than 3, right? And next we just have to subtract the area of the circle, which is what I just did with this. I subtracted the whole area of the circle and I was left with the corners. I have the 4 corners and I only need one of those corners, so I just divide it by 4 and I know exactly what the area of the shaded region is. It's like, what? You can do that? I didn't know that. Like I just didn't, like I said, I didn't have the flexibility or the door open to creativity to problem solving. And that's what I'm learning more and more, is that geometry is just another form of problem solving in which you can actually use a dose of creativity to try to get around it. By all means, you do need to follow the rules, but with those rules intact, you can try to figure out ways to kind of get around. In this case, we can do 64 minus 16 pi over 4, do some beautiful canceling out, and then estimate, and we know that the answer is going to be less than 4, which means that B is going to be greater. I had so much fun just really looking at this in a new light, and I'd love to know if you have any tricks on how you approach math or geometry. Put them in the comments below, and as always, if you have any ideas of things that you want me to cover, then I will do so. I just saw the request on reviewing the Kaplan books, so I'll do so. I'll need some time to get on, to use them and study and see if they do a better job explaining the answers, and I will report back and let you know what I think. If you like this video, please give me a thumbs up. And if you find value in these and want to continue to follow me on my journey, please consider subscribing. I always get excited when I see it. So, you can click my face at the end of the video. You can click at the bottom of here. There's like a nice little watermark. There's another subscribe button. There's all the subscriptions. Just subscribe away. And I'll see you next time.